This video we'll be studying about Kirchoff's laws. Okay. Two laws were given. Okay. Kirchoff laws. Okay. Two laws were given by him. The first one is your current law, and the second one is your voltage law. Okay. We'll be covering this one by one. First law is your Kirchoff's current law, okay. Or you can also say it junction theorem. Junction theorem. Okay. What this law says that the algebraic sum of various currents meeting at a junction in a closed electric circuit is always 0. Okay. Algebraic sum of various current meeting at a junction in a closed circuit will be 0. That means sigma I is equals to, I am not repeating the statement, you can read it by your module or book. Okay. That is sigma I will be 0. Okay. What does this mean? Okay. Firstly, you need to do a sign convention. Okay. Sign convention is that the current heading towards the junction is taken as positive. Okay. Towards, and the current which is leaving the junction, or you can say which is going out of the junction, okay, that is taken as negative. Okay. Suppose the junction, let's say J, there is current coming, going, leaving. Okay. Let's say I1, I2, I3, I4, I5, and I6. What does this law says? That sigma of I equal to 0. So the current coming which we will take as positive. Okay. The current comings are I2 plus I3 plus I5, sorry, I6. Okay. And the current which will be leaving we will take at negative. Okay. Minus I1, minus I4, minus I2. This will be 0. If you transpose this to other side, what will be the final result? I3 plus I2 plus I6 equals to I1 plus I4 plus I5. That means the current, the incoming current is equals to outgoing current. And also the Kirchoff's first law is based on law of conservation of charge. Right? From here you can see that the current, the net current coming to the junction will be equal to the net current that is leaving the junction. Okay. This was your Kirchoff's first law. Now Kirchoff's second law, also known as Kirchoff's voltage law. Right? What does this law says? That around any closed loop of electric circuit, the algebraic sum of all potential difference is equals to 0. Around any closed loop of electric circuit, the algebraic sum of all potential difference right? That means sigma delta V equals to 0. Right? What sign conventions will be taking? Will be taking any potential drop as positive, or you can also take it as negative. Okay, but I will be taking any potential drop as positive, and any potential rise as negative. You can also take at is negative and the other one as positive. Okay, you can do by both the methods, right? Right. So this is your Kirchoff's voltage law. Okay. By this Kirchoff's voltage law will be uh, finding the relation between EMF and your internal resistance of a cell and terminal potential difference. Okay, that we'll be covering in our next video. Okay, we will be finding the relation between EMF and terminal resistance and terminal potential.